What would you be willing to pay to reduce air pollution and improve your health? And how could a policymaker use this information to determine energy policy? This is Arvid from Econ Explains, and in this video we will tackle both of these questions. And these questions are important as reductions in air pollution and improvements in health often come at the cost of higher energy prices, as cleaner energy is often more expensive. But while it is relatively straightforward to calculate the increase in costs arising from cleaner energy, it is much harder to quantify their benefits. But a growing body of academic research does exactly this. And in this video, we will focus on a paper that estimated the benefits of reduction in air pollution in China. Besides discussing this estimation, I will show three really cool evaluations that this paper did. First, evaluating benefits for China as a whole from reductions in air pollution. Second, replacing coal plants with natural gas plants, or alternatively, wind turbines. And third, evaluating the benefits of overturning a decades-old policy in China by finally installing household meters in some cities. Before diving into the paper, let's set the stage by looking at global trends in one type of air pollution, particulate pollution. And this type of pollution can be especially damaging to your health, as this pollution can enter your lungs and sometimes your bloodstream. So in this figure from the Energy Policy Institute of Chicago, you can see the average air pollution levels for China, South Asia, and the rest of the world. And air pollution is measured using PM2.5 on the vertical axis. And PM2.5 is a measure of concentration of particles less than 2.5 micrometers. The World Health Organization recommends a level of 5 micrograms per cubic meter as a safe zone. So as you can see, air pollution is a severe problem. In addition, while the pollution in the rest of the world is relatively flat, China and South Asia experienced about a strong 25% increase from 2000 to 2014. However, since then, China's average air pollution decreased from about 50 to about 30 micrograms in 2020. So quite a substantial reduction. But how can you quantify the benefits of reductions in air pollution? This is where two top energy economists come in, Koichiro Ito from the University of Chicago and Shuang Zhang from the Imperial College of London. And apologies if I get their names wrong. These authors estimated the willingness to pay for a reduction in air pollution for a region in China from 2006 to 2014. And their paper was published in one of the top economic journals, the Journal of Political Economy. Now, the authors approached this question by investigating the demand for home use air purifiers. Because when you install a certain air home purifier, you can remove all indoor pollution and avoid health risks. And so your willingness to pay for these air purifiers is directly linked to your willingness to pay for clean air and your improved health. Specifically, they will estimate this willingness to pay in an area around the Huai River. Because in 1958, the Chinese government introduced a heating policy whereby the citizens north of the river got subsidized heating. As a result, they used more electricity and experienced higher pollution levels. Now, the authors are going to leverage this difference in air pollution around this river to estimate the willingness to pay for clean air. Do note, as the authors point out, that because their estimation happens in cities close to the river, the results might be less reliable outside or for cities further away from the river. If you're interested in more details about the estimation, I will refer you to the paper where the authors spend a lot of time on the estimation. And their approach is frankly quite brilliant. But their main result for willingness to pay is the following. For 1 microgram per cubic meter reduction in PM10, an average Chinese household is willing to pay $1.34 per year. So for each year, you're willing to pay this amount to reduce it by 1 unit. In addition, they can estimate the willingness to pay for other cities, accounting for socioeconomic factors such as income. For China as a whole, they find that the average willingness to pay is $1.24. So let's see this number in action. Because with this willingness to pay in hand, we can move over to evaluating benefits on a larger level. So first, I will show how the authors evaluated the benefits of air reduction for China as a whole, and then I will go into their two policy evaluations. To start off, let's consider how much Chinese citizens could value reductions in air pollution since 2014. Because as you may recall, pollution started to go down in 2014. Now that graph used PM2.5, while the authors used PM10 in their paper. And PM10 is the particles smaller than 10 micrometers, and it thus incorporates PM2.5. In PM10 levels, the drop from 2014 to 2018 went from 124 to 72 microgram per cubic meter, so a decrease of 52. Now, to show the calculations, I will switch over to a table format. In the first column, you can see the name of the value. Then you have the benefits, and then the last column shows the unit of the numbers. So we have a willingness to pay number of $1.26 per microgram. And this willingness to pay, combined with a reduction of 52 micrograms, combines into an aggregate willingness to pay per household of about $65. In other words, the reduction in PM10 from 2014 to 2018 annually is valued by households at about $65. The annual average household income is about $4,800 in 2013, and thus this amount is about 1.5% of annual income. Now, for China, which had around 357 million households in 2014, the total annual benefits are about $23.4 billion, so a very substantial benefit. Now, besides the caveat that the authors had to extrapolate results from their sample to the whole of China, the authors point out that this $23.4 billion benefit is not necessarily arrived from government policy. Other factors might have contributed to the decline in air pollution. But let's move on then to two specific government policies. First, installing household metering, and second, mandating a switch from coal to natural gas or wind turbines. And we'll tackle each of these in turn. To start, the authors considered a policy whereby household metering was installed in 7 cities in China in 2005. And the goal of this reform was to save energy and reduce air pollution by introducing the household metering. Because before, households were paying a fixed amount per month. But naturally, flat rate billing, whereby you pay a fixed fee no matter what, provides no incentives to conserve energy. It's only when you pay for what you use that you might start be willing to reduce your energy consumption. So why does it matter? Well, according to the authors, 10 years after the start of this pilot reform, there's still ongoing debate if this reform actually improved welfare. And the reason for this ongoing debate is that, on the one hand, there's the upfront cost of installing individual meters, which is very visible. On the other hand, the benefits of the decrease in pollution are diffuse, it's for a lot of people, and they're not clearly visible because it's often for your health down the line. With this willingness to pay measure, the authors can evaluate the benefits. Now, again, I'll show the calculations in table format, and I have added letters to each step for you to keep track of the calculations. So you can always pause the video to work through it yourself if it goes too fast. So let's start with the costs. According to the World Bank, the 8-year project of introducing household metering cost about $18 million for the 7 cities. So the abatement cost per year was approximately $2.25 million. Now, what is our willingness to pay to reduce a microgram of PM10 per household per year? The authors estimate that the average willingness to pay in these 7 cities was about $1.62, so slightly higher than the average of their sample. In addition, there are 6.3 million households. So the total annual willingness to pay of all citizens in the 7 cities for 1 microgram is $10.1 million. Now, we need to figure out how much the household metering reduced PM10. And the World Bank reports estimates that the project generated reductions in coal usage of 18.7%. Using additional conversions, the authors estimate that this reduction implies an 11.9 micrograms per cubic meter reduction in PM10 for the 7 cities. This number can then be multiplied by the willingness to pay in the 7 cities to obtain the willingness to pay for this policy, which is about $120 million. Now, we have the numbers to compare benefits and costs. The annual benefits in dollars for the 7 northern cities is $120.6 million, while the annual cost is $2.25 million. So the benefits are almost 54 times larger than the costs. So a huge success. So going back to the debate, while the costs of the metering are upfront, the benefits to the citizens overall are much larger. And thus, the recommendation would be to expand this policy to other cities. So this was policy number 1. The authors also present a second exercise. The authors analyze the benefits of a replacement of coal plants, which are often quite polluting, by natural gas plants or wind turbines. So let's dig in. In this table, I present a replacement exercise, once for wind and once for natural gas. And a third column shows numbers that will be used in the calculations, but that are common to both. And the last column are the units. The authors use an estimate that 6% of particulate pollution in China is emitted from coal plants. Therefore, if 10% of the existing plants' production is replaced by wind power, it will result in a 0.6% reduction in PM10. And the authors use the average nationwide level of PM10 concentration in their data, which is 93 milligrams per cubic meter. So the 0.6% drop would lead to a reduction in the PM10 concentration by about 0.56 milligram per cubic meter. And the authors used the assumption that the replacements would operate for about 30 years. Combining these numbers, the willingness to pay for the replacement policy is $7.7 billion. And data from the International Energy Agency estimated that the total electricity generation from coal power plants in China is around 4.3 billion megawatt hours. Thus, we get that the implied willingness to pay for reduction in air pollution is $17.9 per megawatt hour. And why this unit? It's a unit because it's commonly used in energy studies. For example, here you can see a figure from a report for the European Commission documenting different technologies, and their costs are expressed in euros per megawatt hour. So from a cost-benefit point of view, citizens would prefer the wind turbines over the coal plants if the difference in cost of wind turbines is less than $17.9 per megawatt hour. And a similar calculation can be done for replacing a coal plant with a natural gas plant. Given that natural gas has about 20% of emissions of PM10 relative to a coal plant, you also get very similar numbers to wind turbines. So now it becomes an empirical question whether citizens prefer the reduced air pollution or whether they prefer a lower energy bill. Because based on the research actually, the authors find that the difference in costs between coal and the cleaner technologies in China at that time is higher than the $17 or $14. Thus, based on particle pollution alone, it is not yet desired by the average citizen to change technologies. Of course, this can change as income increases and so willingness to pay goes up, or as the cost difference between the technologies decreases, for example, when coal becomes more expensive or the price of natural gas goes down. In addition, there are other benefits of replacing coal with wind or natural gas. For example, you could add in the value of reducing greenhouse gas emissions and other pollutants. But the amazing thing of this paper is that the authors estimated and thus quantified the benefits of reducing one type of air pollution that is harmful to human health, and they use it to evaluate policy scenarios. So, thank you for watching, and if you enjoyed this video, please leave a comment below and subscribe to the channel.